What's up guys, Patrick here, welcome back, and in this video what we're going to talk about is measures of variability. We're actually going to talk about over the next couple of videos. So this video is going to be more of an introduction, kind of an overview. And variability, another word for it you may see in certain textbooks is spread. So measures of variability, measures of spread, both mean the same thing. And before we get into it, let me kind of show you how this is going to fit in the overall picture. So far we've been talking a lot about data, how to visually show it, whether through histograms or stem leaf plots or density curves. What we did in the last couple of videos was we talked about how we can look at the central tendency of data. And we did it with three measures, so the mode, the mean, and then the median. But central tendency doesn't give you a full accurate picture of how data is behaving. And so we also have to look at the variability of the data. And I'm going to show you in this video through an example why this is really important, how you can have data that has the same central tendency, but that variability is totally different. And so with variability, we're going to go over a bunch of tools. One tool I'm going to introduce in this video is something called the range, which is a super simple calculation, really easy, really quick. But the problem with it is it's affected by certain things really easily. So I'm going to show you why, even though it's a simple calculation, it's a simple tool to look at the variability, it does come with some defects. Another tool that we're going to cover in future videos is taking the data and splitting it up into quartiles. And related to quartiles is there's a way to actually display the data then through something called a box whisker plot. And then another measure of variability that we'll go over, probably the one that requires the most algebra, is going to be the standard deviation. And actually related to standard deviation is variance. The standard deviation is just the square root of the variance, so I'll kind of group those together. And so these are the tools that we're going to be going over in this video and then in the next couple of videos. So let's jump into an example here. Let's say that the test marks for two sections of the same course are collected below. So this is section 1, this is section 2. Both sections have 10 students each, so notice that there are 10 marks in each of the sections. And we have to find the mean, median, and mode for both sections. And notice that the data is nicely arranged for us from smallest to largest. That's not always going to happen. If this was all mixed up, then we'd have to arrange it from smallest to largest in order to find that median. We don't need it for the mean and the mode, but for the median we would. But it's already arranged for us, which is nice. So starting with section 1, what would the mean be? Well, the mean, if you remember, it's basically the sum of all these values divided by the number of observations. So if you sum all these numbers up, you would get 750 divided by 10, so 75 is the mean of this section over here. What's the mode going to be? Remember, the mode is the observation that has the largest frequency, that shows up the most. And notice that out of all of these, the one that shows up twice is 71. No other mark shows up twice. So this frequency of 2 with that 71 makes it the mode. And then the median is going to be what? Well, there's 10 observations, which is an even number of observations. So remember, what's the position of the median? It's n plus 1 divided by 2. So 10 plus 1 divided by 2 would give us 5.5. So it's going to be in between the 5th and the 6th observation. So 1, 2, 3, 4, 5, and 6. So it's going to be in between those two. So if you crossed out 4, you'd have 2 remaining observations in the middle. So we got to take the average of those 2 observations. So we would do 74 plus 77 divided by 2, which would give us 75.5. And so that ends up being the median for section 1. Okay, so let me write this here. So 75.5, we got 71 for the mode, and then we got the median being 75. All right, that's for section 1. Now what about section 2? What's the mean going to be? Well, same thing. We would sum all of these up, divided by the number of observations. And if you sum all these up, you actually get the same sum as section 1, which would be 750 divided by 10, the number of observations, you would get 75. What's the mode going to be? Notice that, again, the mark that shows up the most frequently is the 71. It shows up twice, and no other mark shows up more than once. And so 71 ends up being the mode. What's the median going to be? 10 observations, 10 plus 1 divided by 2, 5.5. So it's going to be the average of the 5th and the 6th position. 5.5 is in between 5 and 6. 1, 2, 3, 4, 5, 6, so it's going to be in between these two. And so if we do 80 plus 71 divided by 2, we would get 75.5. Which, notice, it's the exact same median as section 1. And so notice that all 3 measures of central tendency for section 1 and section 2 are the exact same thing. The mean, mode, and median are the exact same for both sections. However, if you look at the data, notice that it's really different, because notice with section 1, the data is kind of varying from 68 to 82, meaning the difference between the largest and the smallest value is 14. Right? So it's kind of in that 70-ish range. Versus the data over here, notice it's really spread out. We have a bunch of marks in the 50s, and then we have a bunch of marks in the 90s. Right? And if we take the difference between that largest value and the smallest value, notice it's 45 compared to 14. So that data is more spread out, meaning that it's varying more. And actually, that difference between the largest value and the smallest value in a set of data is called the range. So notice that the range is 14, and then for section 1, and then over here, the range is a lot bigger. It's 45. And so that's why it's important to measure both central tendency, like we did, but in this case it was the same, and variability. Because if you just measure one, and you look at just one, you may think that the data is similar, it's the same, but when you actually look at the variability, it's very different, right? Again, this data is more spread out, it's varying more, and we could see that with the range, it's a larger range. Now, notice that the range, it's a very simple calculation. It's just the largest value minus the smallest value. The problem is with range is that it is easily affected by outliers. It's easily affected by outliers. So if we go back to section 1 where most of the data is in that 70-ish range, but instead of that lowest mark being 68, let's say we made the lowest mark be, I don't know, let's say 20. Then what would the range be? Notice the range would be then 62. So notice that the range here would be higher than this range, But notice that because that's an outlier, we can kind of ignore that. The bulk of the data is still happening in that 70-ish range. So even if there was a 20 here, I would say that this data varies more than this data here, because that 20 was an outlier. However, it would bring up that measure of the range if we just looked at the range. And so that's the problem with range, is that it's easily affected by outliers. It's less resistant to outliers. And so what we need to do is we need to introduce some more robust calculations for variability that aren't as affected by outliers, that are more resistant to outliers. And that's what we're going to cover in the next couple of videos. So remember those different tools of variability? We went over the range in this example, kind of talked about its defects. And in the next video, we're going to talk about another tool for variability called quartiles.